All right, so we're going to do some reverse chain rule question with different functions. Say, for example, we're going to do something about logarithm function and exponential function today. All right, reverse chain rule. So start with the actual formula. So the reverse chain rule for the exponential function will be integrate f dash x e to the power of fx dx. So it's like an composite function, as you can see here. That's e to the power of fx. All right, the power is fx. It can be any functions. And, it can be a trigonometric function. It can be an exponential function. It could be another exponential functions here. And how do we integrate this? Now, the formula tells you the answer is just equals to e to the power of fx plus c. Now, of course, the most important thing about this is you need to have the f dash x right in front of this, e to the power of fx. That's very important. You need to have the f dash x. So this is the key. If you don't have the f dash x in the front, you can't use the reverse chain rule to answer the questions. All right, now let's just put this one into an example to see how do we answer some interesting questions there. So, for example, the first one is something that's really simple. We have e to the power of 5x and then dx. Now, I do understand that you probably will have some formula you can use, but the idea behind is you think about what is the derivative of 5x. All right, the derivative of 5x is equal to 5. So if you differentiate 5x, and the answer is equal to 5. So that tells you that you do need to have the f dash x right in front of this e to the power of 5x. So you need to have 5 being placed in front of e to the power of 5x. So the way to do this question then would be, if we do step by step, you're adding a 5 here, all right, and then you're going to add 1 over 5 outside, which I explained to everyone before. All right, the reason for that is because you don't want to change the question. You just want to balance the question here. So if you add a 5, or if you times a 5 here, you need to times 1 over 5 outside to change it. Now this becomes the actual formula. All right, the reason for that is because this is e to the power of fx. So that's fx. And then what's in front of here is f dash x, which is the derivative of 5x. And then that becomes the answer. So when you integrate it, you still keep 1 over 5, but you copy down e to the power of 5x down, all right? And then you plus c. So that way you can integrate this one quite easily. So you don't really need to know the formula. You don't have to memorize the formula. All you need to know is the process behind. All right, let's try another one here. What about if the question gives you 4x and then it's e to the power of 5x squared plus 6 dx. All right, it's the similar, very, very similar question, all right, to the question we did before. It's like, the first thing you do is you check the power, that's the fx here, and then you start to differentiate that, 5x squared plus 6. So the derivative of this is equal to 10x. That means what you need to have in the front here has to be 10x. Now you have 4x. It's not that hard to change the 4x to 10x. All you need to do is move the 4 outside. So you have a space that you can actually write the numbers that you need. So leave a space here if you want. Copy the rest of the things down. And remember what you need to add is the number 10, right? We need to add a number 10 here. And once you add, times by a 10, all you have to do outside is to divide it by 10. So that way, it is balanced again. So now that becomes 2 over 5. Now you can integrate. Now remember, the way I remembered how to do it is this part disappeared with the formula, and then you just have to copy down this part down. So that gives you e to the power of 5x squared plus 6 plus c. And between these two is multiplication. And that way, you also answer the question. All right, so it's another pretty easy and straightforward questions here. Now let's do some harder question there. How about this question here? Let's try this one. So integrate e to the power of, let's do x to the power of half dx. And then that's 1 over square root of 2, square root of x, I guess. square root of x. All right, let's try this one to see if that question works. All right, when you first look at a question, now sometimes they do give you a question in this format. So you've got f dash x or a kind of f dash x in the front, and then you've got a function here. That way, it's a bit easier for you to answer the question. But sometimes they don't have to give you the question like this. They can give you a slightly different question. So let me just remove that question here and try to give you a really complicated question. And usually students, get a bit confused how to do it. Like the question like this. All right. So as you can see here, they start to put this as a denominator. And then the student will find, how do I do this question here? What is the method that should I use? The first step of what I want you to do is to change that into, not into a fraction, right? So remove the fraction. So change that into 1 over square root of x, and you multiply by e to the power of x to the power of half dx. Now, once you finish that, remember this power here is the fx. Now, try to differentiate that fx, and hopefully you can see that the derivative that's in the front. Okay, if it's not, then you probably need to modify that derivative slightly. So if we differentiate that, we get a half x to the power of negative half, and then we use index law. We can change that into half 1 over square root of x. So you do have 1 over square root of x here, which is really good. All right, and all you need to do is right in the front, you do need to have a half. So how do I do it? And that's easy. So we need a half. So let's put a half here. And let's put a 2 outside, because once you put a half and 2, they cancel out. All right, and then we still write down 1 over square root of x, e to the power of x to the power of half dx. All right, so that way you've got everything you need. All right, so let me show you one more time. So this is f dash x, and this part is fx. And I just follow the formula. And remember the formula here is integrate f dash x e to the power of fx dx is equal to e to the power of fx plus c. Alright, so it's in the correct formula, and then we can actually start to answer the question. So that gives us 2, and we multiply by this entire answer here. Alright, so we just copy everything down. So that becomes e to the power of x to the power of half and plus c. And that way you can answer the question. Alright, so this is just an example of a reverse chain rule being used in an exponential function. We can also have a reverse chain rule that being done in using a logarithm, so like in the logarithm function as well. Alright, so let's move on to the logarithm then. Now for the reverse chain rule, that's in terms of logarithm, firstly let me just give you the formula here. Alright, so the formula for that is when we integrate, we have integrate f dash x on the top over fx dx. Alright, and then the integration of that is going to be ln absolute value fx, absolute value plus c. Alright, now it's really important why it's absolute value. You can check out my later videos and I'll explain to you why it's absolute value. Okay, so now let's have a look. This is the most important part, right? You do need to have the f dash x right in the front, on the denominator. So it's very similar to this formula here, 1 over x. When integrated, it is equal to ln absolute value of x plus c. But this time, the denominator is not just x. The denominator is another function. It's like a composite function type, all right? You've got another function here. And the numerator is the derivative of that function here. So this is really important that you need to have the numerator there before you can integrate. Alright, so I'd like to show you a few examples. Alright, so let's just call this as example A. So we'll start again with something that's really simple, alright, to give you some idea how to do the question. So if we try to integrate x over 3x squared plus 7 dx. If that's the question. Now, all I want you to do is think about it. This is fx. The top one is f dash x. Alright, or it should be the f dash x, but right now it's not, right? So I guess the first step you do is try to differentiate what's 3x squared plus 7. And that is equal to 6x. Alright, so as you can see, all we need to put a 6 right in the front, right? We need to have a 6 here. So that we need to have that number to make sure the top one is the derivative of the denominator. So then the second step will be is equal to, all right, you're going to add a 6 on the top, all right, and then you're going to put 1 over 6 outside to balance it, and then that gives you denominator is 3x squared plus 7 dx. Okay, and then that gives you the formula. So now it's equal to 1 over 6, and all you have to do is put a log base e, and then absolute value, you write down the denominator as 3x squared plus 7 plus c, and you solve the question. So that's a simple question here, really easy. Usually what I ask my students to remember is whenever you see a fraction, if you ask to integrate, then your first reaction is to check if you can differentiate the denominator to see if the denominator, the derivative of the denominator is the numerator, all right? If that's, if the answer is yes, then obviously you're going to use the integration in terms of logarithm, right? Okay, so how about this question here? It's a really tricky question, but I really like this question here. 1 over x ln x dx. All right, I really like this question. It's such a nice question here. So if you look at this question, it's a fraction. And I remember I told you, if it's a fraction, you start to think about whether this is a logarithm integration. So if we try to let this one to be fx, then if we want to differentiate that fx, d over dx, try to differentiate that function here. So x ln x. Now we're going to use the product rule to differentiate that. So when you differentiate this one, that's equal to 1 times by ln x plus, and then you differentiate this part, 1 over x times by x. So that gives you ln x plus 1. Now clearly you can see that one is different to the numerator. All right, so numerator is only equals to 1, but however the derivative of the denominator is not equals to 1. All right, so how do we solve this question here? Is there any way we can do this question? It's a really tricky question. So right now this method is not going to work. Okay, it's not going to work. Nope. So how do I do it? Well, I guess the step what you need to do is, instead of using the denominator equals to x ln x, you do need to change the format. All right, so let's just take this x outside, like becomes 1 of x, all right, and then it's multiplied by ln x dx. And then what you do is you are going to move this one to the numerator, like just times them, all right, to the numerator, and you get 1 over x over ln x dx. Once you get to that point, you should notice that the denominator is just simply ln x. So that gives you the derivative of ln x is just equals to 1 of x, which you do have 1 of x on the top. Great. All right, that becomes the formula. All right, so what is the formula? The formula is f dash x over fx dx is equal to ln absolute value of fx plus c. So you've got a formula here, then that gives you the answer ln absolute value, another ln x inside plus c. So it's a really interesting question. All right, if you're treating like the entire denominator as the function fx, it's not going to work. And you're going to break down this part into two separate fractions. One is 1 over x, the other one is 1 over ln x. And then you move 1 over x to the top numerator, and then it just suddenly becomes the correct formula to use. So really interesting and nice question to do. All right, so how about we try another one? All right, so this time I'm going to do a question in terms of trigonometry. So it's like, how do we integrate tangent x dx? All right, when you integrate tangent x dx, the way to do it is try to change the tangent using the ratio formula, and the tangent is equal to sine x over cosine x. Now that becomes a fraction, so I hope you realize that if you see a fraction, then we start to think about what is the derivative of the denominator, and that's cosine x. Okay, so when you find the derivative of cosine x is equal to negative sine x. So then you start to compare. All right, you do have sine x on the top, and all you need to do is put a negative right in the front. And then make sure you also put a negative outside. That becomes the correct formula. So you do have everything you need. So what do you have on the top here is the f dash x, and the denominator is fx. So then it's just equals to negative ln, that negative still there, ln absolute value cosine x plus c. Okay, so it's another really interesting question here where you can integrate tangent x by changing the tangent x into sine x over cos x, and you apply the integration, the logarithm integration, thinking about what is the derivative of the denominator, and then try to compare to see if you have that on a numerator or not. All right, so that's the examples of using reverse chain rule on both exponential function and reciprocal function, where the answer is logarithm function there. It's really interesting, but try to understand that the most important thing with these two formula here, the most important thing is you do have the f dash x right in the front before you can integrate. Okay, we're going to move on to other integration in the future lessons. Stay, just subscribe my lessons, and I'll see you next time. Thank you.